Okay, so now we've been working on some investigations and learning a bit about the unit circle. So we are going to formalize some of this information today and start talking a little bit about how these values are going to apply in the different ways that we're going to use them. So we've talked about several times already that in geometry, we are focused on triangles and we're measuring in degrees. And so the domains that we worked on in geometry were based off of that. But in calculus, our goal is to be able to study functions whose domain is the real numbers. And so in order to do that, we have to move to the circle rather than a triangle. And we will be using radians as well. So we know that the unit circle is a circle of radius 1, where its center is at the origin. And again, we know that the length of the intercepted arc around the entire circle is 2 pi. And that's something that we've talked about. But again, the reason for that is that the circumference is equal to 2 pi r. And we know in this case that the radius of the unit circle is 1. So the intercepted arc has a length of 2 pi units. All right, so again, we've talked about the reason why the unit circle is so helpful is because numbers like 1 are much easier to work with. And because we choose a radius of 1, in a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. So if we look up here, whatever t is here, so whatever this angle theta is, the length of this arc is also going to be equal to whatever theta is. That's only true on the unit circle because of the radius of 1. Any other circle, that's not going to be true. This is why the unit circle is so nice. We've already talked through the 6 trigonometric functions in terms of the unit circle. So if we're looking at some point P, xy, which is on the unit circle, it's wherever the radius touches the circle, that ordered pair, then the sine of that angle is equal to the y coordinate of the ordered pair, the cosine is equal to the x coordinate, and so on. Now, I think it's easy to remember that C comes before S, X comes before Y. So cosine is the X, sine is the Y. That'll help you keep track of the order, okay? Now, the domain and the range of the sine and cosine functions is important to consider. So if we think of the function in terms of the y value is equal to the sine of t, that's what we just talked about here with these 6 ratios. If the y value is equal to the sine of t, because the circle has a radius of 1, that means we restrict the y value between -1 and +1. That's it. Now the domain is anything. We've talked about we could rotate 60 times around the circle and land in the same spot. So we can put in any value, positive or negative, for t, but the value of the sine of t, which is going to be your y coordinate, is always going to be a number between -1 and +1. Similarly, if we consider the x coordinate is equal to the cosine of t. For the exact same reasons, horizontally then, we're also trapped between -1 and +1. The angle t can be anything, but the value of x is only going to be between -1 and +1. This is information that you need to have memorized. So this is flashcard information. Put that on a flashcard, the domain and the range of sine and cosine. Now, we have talked about even and odd functions, and it works exactly the same way for sine and cosine. So the cosine function is even. And that's because of the definition of an even function. And this is going to be because the cosine of -t is the same as the cosine of positive t. Remember our test for even and odd functions when we were talking about non-trigonometric functions is you evaluate f of -x. In this case, we're looking at -t. If everything stays the same, your function is even. If everything switches to the opposite, your function is odd. Now, the cosine function is even because if I rotate positive t radians in this direction, I hit this x value right here. that is going to be the same x value if I rotate in the negative direction. So it doesn't matter, my x value is going to stay the same. Now the y value, I have a positive y here and I'm going to have a negative y down here. That makes the sine function odd because the sine of negative t is going to be the opposite of the sine of positive t. And so this is another thing that needs to go on a flashcard. All you need to remember is sine and cosine. And really all you need to remember is that cosine and its reciprocal secant are the only two that are even. Everything else is odd. That's how I remember it. I know that cosine is even, so therefore secant is also even, but everything else is going to be odd. Now, how could we use this? Okay, well, going backwards around the circle is not as easy to count as it is going forward. So since I know that cosine is even, I know that the cosine of negative pi fourths is going to be equal to the cosine of positive pi fourths, which we know from our unit circle is equal to the square root of 2 over 2. Now, tangent is odd. So the tangent of negative pi fourths is going to be the opposite of the tangent of positive pi fourths. Now, you don't really need those parentheses there. You can leave those off if you want in either case. So the tangent of pi fourths, remember, tangent of t is equal to y over x. Well, at pi fourths, both x and y are square root of 2 over 2. So the tangent at pi fourths is 1, and the opposite of that is negative 1. All right. Now we're going to start introducing some of our fundamental trigonometric identities. These need to go on flashcards. These are rules that you need to have memorized. Now, some of this you already know. For example, the reciprocal identities. We already know that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So if I know sine, I can just flip it over to figure out what cosecant is. Similarly, if I know cosecant, I can flip it over to figure out what sine of t is. And so that reciprocal relationship, you just need to know which ones pair up. Okay. And remember this notation of 1 over something, that is the notation that stands for reciprocal. That's going to flip anything over. 1 over 1/2 makes it 2. So that's what that means. Now, the quotient identities are based on, remember, the fact that tangent is equal to y over x. And we also know that sine of t is the same as the y coordinate, cosine of t is the same as the x coordinate. So we know that the tangent of t is equal to the sine of t divided by the cosine of t. And then because cotangent is the reciprocal, that means cotangent of t is equal to cosine of t divided by sine of t. So we can use each of those identities to find all 6 trig functions with very limited information. So for example, on number 2, they give us the sine of t is equal to 2 over 5, and the cosine of t is equal to the square root of 21 over 5. So to start, let's set up our 6 trig functions. So the sine of t is equal to 2 over 5. We already know that. The cosine of t is equal to the square root of 21 over 5. Now, tangent of t, we're going to have to do some work. But we know, based on our quotient identities, that the tangent of t is equal to the sine of t divided by the cosine of t. So that's going to be 2/5 divided by the square root of 21 over 5. Remember that with fractions, we keep, change, flip. So the 5's cancel out, and we get 2 over the square root of 21. And then we need to rationalize that. So we multiply by the square root of 21 over the square root of 21. And that tells us finally that the tangent of t is equal to 2 root 21 over 21. And that doesn't simplify any. Once we have these 3, the other 3, are very simple because they are all reciprocals. So sine and cosecant of t are reciprocals. So cosecant of t is going to be 5 over 2. Secant of t is going to be 5 over the square root of 21, which rationalizes to 5 root 21 over 21. And then the cotangent of t, again, choose the form that's easy to flip over. If we flip there, we don't need to rationalize. So this is going to be square root of 21 over 2. So there's our 6 trig functions. So we used quotient identities to figure out tangent based on what we were given. And then we used reciprocal identities to figure out the other 3. Okay. There are some other trigonometric relationships that we will need to know as well. These are the 3 Pythagorean identities, and these are very, very important. These come up a lot. These are probably the identities we use the most in calculus, okay? These come from the equation of the unit circle, which is x squared plus y squared equals 1. So if x is equal to cosine and y is equal to sine, then we get that sine squared of t plus cosine squared of t is equal to 1. Notationally, this is really important. We write the squared. If I want to show that cosine of t is squared, to avoid having to use so many parentheses, we put the squared on the cosine. Now, this is very different from saying the cosine of t squared, because in this case, you're only squaring the t, not the cosine. So those 2 things are not the same. All right, so we want the sine of t squared, the cosine of t squared, not the cosine of t squared, is what we're looking at here, okay? Now, here's a little trick to remember these. Sine squared plus cosine squared equals 1. That one follows pretty directly from the equation of the unit circle. These are kind of goofy, but I learned these one year, and now I've never forgotten these identities. And it is that tan ones are sexy. Tan ones are sexy. And then the second one is cotton ones are cozy. Those 2 phrases will help you remember the other 2 kind of weirder identities. So they're kind of silly. Tan ones are sexy, cotton ones are cozy. Cozy is for cosecant. Cotton is obviously for cotangent. Tan is for tangent. Sexy is kind of for secant. So that's how you can remember those. And if you don't like that, then you can come up with another way to do it. So here's how we can use these identities, just the same way as before. You just kind of got to think of what formula can you use that's going to be helpful. So given that the sine of t is equal to 3 over 5 and 0 is less than or equal to t is less than pi halves, find the value of cosine of t using a trigonometric identity. Now, why in the world would they give us this information that t is between 0 and pi halves? Because that tells us that we are in quadrant 1. Remember, this is 0, this is pi halves. That's important to know because there's 2 different quadrants where cosine is positive, because cosine is the x. Remember, we said cosine is even. So cosine of positive t is the same as cosine of negative t, but we know that this is going to be a positive x and a positive y value based on being in quadrant 1. That's probably important. Okay, so given that the sine of t is 3/5, we want to find the value of cosine of t. I need a rule that relates both sine and cosine. Now, the quotient rule might do that, but we don't know cosine and we don't know tangent, so that's not helpful. So we're going to have to use the Pythagorean identity to do that. We know that sine squared of t plus cosine squared of t is equal to 1. And so we will take the sine of t, which is 3/5, and square it, plus cosine squared of t, that we don't know, is equal to 1. So that's 9 over 25 when we square that. 1 is 25 over 25. We need a common denominator. If I subtract 9 over 25, we get that cosine squared of t is equal to 16 over 25. Then we're going to take the square root of both sides, which tells us that the cosine of t is equal to plus or minus 4/5. Now, how do we know whether we want the positive or the negative? That's why they told us this information. We are in quadrant 1 based on what was given. So that's how we know that the answer is that the cosine of t, that's what we were trying to find, is equal to positive 4/5. Notice we did not find the angle. We don't know what t is. They weren't asking us about that. We were trying to find the ratio. What is the cosine of t? And so that's the answer. Will you go ahead and pause the video and try number 4 yourself? I'll be back in 3 seconds. Alrighty, so you should hopefully get that cosine of t is positive square root of 3 over 2. Again, we want the positive because they told us we were in quadrant 1 once again, but always make sure you include that plus or minus because they could have told us that we were in quadrant 2, for example. If that was the case, then we would choose the negative because in quadrant 2, x is negative. Okay, last thing is that when you want to put the reciprocal functions into your calculator, you don't have those buttons. So you have to rewrite them in their reciprocal form. We also are working in radian mode now. Notice that for A and B below, neither one of these has a degree symbol. So that means we are in radians. So the first thing I want you to do is change the mode on your calculator and then go ahead and put both of these in and see if you can get the same answer as me. Cosine, you have a button for that, but for cotangent, you're going to have to type in 1 divided by cotangent of 1.2. So change your mode, plug those in your calculator. I'll be back in 3 seconds with the answers so that you can check yourself. All right, these are the answers that you should get. One last time, you need to type in 1 divided by, sorry, that's not what I meant to write, tangent of 1.2 to get this answer. You cannot use the tangent inverse button because again, that -1 stands for inverse, not the -1 power. So this will not work. That will solve for an angle. It will not evaluate the ratio, which is what we want. All righty, that is it. You can go ahead and start working on your homework now, and we will be finishing up this unit in the next video.